Do you want to crack your next AWS interview like a pro? Whether you're just starting out or if you want to become a cloud professional, you're in the right place. In this video from K21Academy, we're breaking down 25 hand-picked AWS interview questions that interviewers actually ask. We have split them into beginner, intermediate, as well as advanced levels, with clear answers, expert tips, and especially no fluff. Also, if you want to kickstart your AWS Cloud career, join K21Academy's free masterclass. Learn a proven roadmap and land your first AWS job with hands-on labs as well as real-world projects. So reserve your free seat now by clicking the link in the description below. And with this, let's get started.
Okay, so we'll start with beginner level question. Our first question is, what is AWS Identity and Access Management? So IAM stands for Identity and Access Management, and it's all about controlling who can access what in your AWS account. So with IAM, you can create users and groups, give them roles, and define what they are allowed to do using something called policies. So for example, let's say you have a developer on your team. So you can create an IAM user for them and give them permission to access only Amazon S3 and Lambda. So they won't be able to access EC2 or billing, for instance, unless you allow it. So you're giving them exactly what they need and nothing more. And this brings us to a key concept called the principles of least privilege. It just means giving users only the permissions they need to do their job, which helps keep your AWS environment secure. And here is a quick tip. Like from the interviewer side, you might get a follow-up question like, what's the difference between a user and a role? So just remember, a user is a specific identity for someone, while a role is more like a temporary permission set that can be assumed by users or services. So IAM is one of the core security services in AWS. So having a good grip on it is a big plus in interviews. So now let's move on to the second question, which is, what is Amazon S3 and what are its use cases? So Amazon S3 stands for Simple Storage Service, and it's one of the most widely used services in AWS. So in simple terms, it's a place to store your files in the cloud, anything from photos and videos to backups, logs, or big data. So what makes S3 powerful is that it's highly scalable, super durable, and very secure. So you can store a few megabytes or petabytes, it doesn't matter. Your data is stored as objects inside buckets, and you can access it anytime you want. So now one thing interviewers love is when you connect a service to real world use case. So here are a few examples. For example, you can host a static website directly from S3. You can just upload your HTML, CSS and JavaScript files. Also, you can use it to store backups or logs from your apps. It's great for achieving old data that you don't need often, or even can act as a data lake where you dump huge amounts of raw data for analytics later. It also has features like versioning, for example, to keep track of changes, and lifecycle rules to automatically move or delete old data, and also access control to manage who can do what. So for example, from the interview side, if you are asked about storage classes, you can mention that S3 offers different classes like Standard, Intelligent Tiering, and Glacier, each optimized for different use cases and cost levels. So saying that shows you understand how to balance performance and cost in real scenarios. So now that you got a clarity on this, let's move on to the third question, which is, what are IAM policies and how do they work? So basically IAM policies are permission rules written in JSON format. So these rules define what a user, group or role is allowed or not allowed to do in your AWS account. So each policy is made up of one or more statements, and every statement has a few key parts. The first one is the effect, which is either allow or deny. The second one is the action, for example, what they can do. And the third one is the resource, which is what they are acting on, like a specific S3 bucket or EC2 instance. So let me give you a quick example. Imagine you have a user who only needs to read data from an S3 bucket. So you can attach a policy to that user that allows on that specific bucket, but blocks them from uploading or deleting anything. So that's fine-grained access control in action. So it's always good to mention in an interview that IAM policies support both inline and managed policies. So basically, inline policies are attached to a single user or role, while managed policies are reusable across multiple users or role. Also, interviewers might ask how AWS evaluates multiple policies. So here's a quick rule. If there's a deny anywhere, it allows wins, even if another policy says allow. So IAM policies are a key part of AWS security, and showing you understand how they work, especially with real examples, can really set you apart in interviews. Now our fourth question is, what is an EC2 instance? So you can think of an EC2 instance as a virtual server running in the AWS cloud. So it's basically your computer in the cloud, and you can use it to run websites, applications, databases, pretty much anything you would run on a physical server. Now what makes EC2 really powerful is how flexible it is. You can choose your operating system, storage type, and even how you want to pay. AWS offers options like on demand for pay as you go, reserved instances if you want to save money for long term use, and spot instances for super low repeat, and spot instances for super low cost computing if you can handle interruptions. So, for example, let's say you want to host a simple website. You can spin up an EC2 instance with Ubuntu Linux, install a web server like an Apache, and boom, your site is live on the internet. So in an interview, if they ask about scalability, you can mention that EC2 integrates with services like auto-scaling and elastic load balancing. This helps you automatically adjust the number of instances based on traffic, so your app stays faster available. So basically, in short, EC2 gives you the flexibility to run almost anything in the cloud without needing to buy or manage physical servers. Now our next question is, what is the difference between public and private subnets in VPC? So in AWS, a VPC is like your own private network in the cloud, and inside that VPC you create subnets to organize your resources, and these can be either public or private. So public subnet is connected to an internet gateway, which means the resources inside, like web servers, can be accessed from the internet. So if you're running a website, your EC2 instance will typically sit in a public subnet. Now, a private subnet, on the other hand, doesn't have direct access to the internet. It's usually used for backend services like databases or internal APIs, things that you don't want exposed publicly. So, for example, let's say you are building a web app. Now, you might place your front-end web servers in a public subnet so users can access them, but put your RDS databases in a private subnet to keep it secure and away from the internet. Now, if the interviewers dig deeper, be ready to talk about using a NAT gateway. So this allows instances in a private subnet to outbound connect to the internet without being exposed to incoming traffic. So now let's move on to our sixth question, which is, what are S3 storage classes? So now S3 offers several storage classes, and each one is designed to suit different types of data and access needs. Now here's a quick rundown for the main ones. First one is S3 standard, is for frequently accessed data. So you can think of it like your go-to storage for things you need fast access to, like active website files or real-time data. Then we have the S3 intelligent tiering, which is a smart choice because it automatically moves data between two access tiers based on how often it's used. So if something isn't accessed often, it will move to a cheaper tier without you having to manage it. So next there is S3 standard IA and S3 one zone IA, which are for infrequently accessed data. So the main difference between these is that one zone IA stores data in a single availability zone, which is cheaper but riskier if that zone goes down. And finally, we have the S3 Glacier and S3 Glacier Deep Archive, which are for long-term archival storage. So these are much cheaper than the others but take longer to retrieve. So they are perfect for data that you rarely need to access, like old backups or archives. So for example, you might store real-time application data in S3 Standard for quick access, but move old log files or backups to S3 Glacier to save costs, since you only need them if something goes wrong or for compliance. So for example, if the interviewer asks how to lower costs, you can mention that choosing the right storage class based on access patterns can significantly reduce your S3 bill. For example, intelligent tiering saves you money by automatically moving unused data to cheaper storage without requiring manual intervention. So by understanding these storage classes, you'll be able to optimize both performance and cost efficiency in your AWS environment. Now our seventh question on the list is, what is auto-scaling? So auto-scaling is a service in AWS that automatically adjusts the number of EC2 instances based on demand. So when your application experiences more traffic, auto-scaling adds more instances to handle the load. And when the traffic drops, it removes the extra instances to save costs. So it's all about maintaining high availability without overpaying for unused resources. So for example, let's say you're running an online store and there's a huge Black Friday sale. So autoscaling detects the spike in traffic, maybe through a CloudWatch alarm tied to CPU usage, and automatically launches more EC2 instances to keep the site fast and responsive. So once the sale is over and traffic drops, it will scale back down to avoid unnecessary charges. So if you're asked how auto-scaling works, you can mention the use of scaling policies and CloudWatch metrics like CPU utilization, request count, or even custom metrics to decide when to scale in or out. Also, you can highlight that auto-scaling is often paired with a load balancer. So the incoming traffic is evenly distributed across all active instances. Now let's move on to the next question, which is what is Amazon RDS? So RDS stands for Relational Database Service, and it basically takes care of all the heavy lifting when it comes to running a database in the cloud. So instead of installing and managing MySQL, PostgreSQL, or Oracle manually on an instance, you can just let AWS handle it for you with RDS. So it supports popular database engines like MySQL, PostgreSQL, SQL Server, Oracle, and even Amazon Aurora, which is AWS' own high-performance database. Now what's great is that RDS takes care of things like automatic backups, software patching, replication, and failover. So your database stays up to date, secure, and highly available. For example, let's say you're running a production MySQL database. With RDS, you can enable automatic daily backups and set up multi-AZ deployment for high availability and scale up your storage or compute power with just a few clicks, no downtime, no manual intervention. So in interview, if they ask you about the difference between RDS and managing your own database on EC2, highlight that RDS is fully managed, while EC2 gives you more control but also more responsibility for maintenance. Also mention features like read replicas and multi-AZ failover for performance and availability. These are things interviewers love to hear. So if you're looking for a reliable, hands-off way to run a relational database, RDS is usually the first place to start. Now let's move on to the ninth question, which is what is AWS Lambda? So AWS Lambda is a serverless compute service, which basically means you can run your code without provisioning or managing any servers. So you must write your function, choose when it should run, like when a file is uploaded to S3 or an API is called, and AWS takes care of the rest. It automatically scales up or down based on how many requests are coming. And the best part, you only pay for the actual time your code runs, down to the millisecond. And here's a quick real world example. Imagine someone uploads an image to your S3 bucket. That event can automatically trigger a Lambda function that resizes the image and stores a thumbnail version in another bucket. All of that happens behind the scenes, no server setup, no manual work. So Lambda supports multiple programming languages like Python, Node.js, Java, Go, and many more. So it's flexible no matter what you're working with. So if you are asked about use cases, definitely mention event-driven applications, API backends, and automation tasks like cleaning up data or sending notifications. Also mention the concept of cold starts. So that's when a function takes slightly longer to run the first time after being idle, which shows you know the pros and cons. So Lambda is perfect when you want to build lightweight, event-driven apps without managing infrastructure. It's fast, efficient, and super cost-effective. So now let's move on to our last question of the beginner level, which is what is VPC in AWS? So VPC, or Virtual Private Cloud, is basically your own private network space inside AWS. So you can think of it like a customizable data center where you can control everything about how your resources connect and communicate, just without the hardware. So with the VPC, you can define your own IP address range using CIDR blocks. You can create subnets, both private and public. You can set up route tables to manage traffic flow. You can use security groups and network ACLs for access control, and add things like an internet gateway for public access or a NAT gateway so private instances can reach the internet securely. So for example, let's say you're deploying a secure web application. You would put your web servers in a public subnet and your databases in a private subnet. That's all done inside a VPC. And if you're asked about why VPCs are important, emphasize control and security. Mention how you can create isolated environments for different applications, enforce least privilege access, and even connect your own premises networks using a VPN or direct connect. So that was it about the beginner level questions. Now let's move on to intermediate level. So in the intermediate level, our first question is what is the difference between IAM user and IAM role? So an IAM user is basically a real person or an application that needs to interact with AWS. It has long-term credentials like a username or password or access keys. So you typically create IAM users for team members or apps that need direct access to AWS services. Now on the other hand, an IAM role is like a temporary identity with specific permissions. So it doesn't have permanent credentials. Instead, it can be assumed by trusted users, services, or even applications for a short period of time. So, for example, let's say you have an EC2 instance that needs to access an S3 bucket. So, instead of storing access keys in your code, which might turn risky, you can assign an IAM role to the EC2 instance. So that way it gets the necessary permission securely and temporarily, and AWS manages the credentials behind the scene. So in an interview, if they ask when to use what, you can say, you can use an IAM user when a human or app needs long-term direct access. And you can use an IAM role when you want to grant temporary access, especially for services like EC2, Lambda, or cross-account access. So roles are also essential for improving security and flexibility. Now let's move on to the next question, which is, what are EC2 spot instances and when you should use them? So spot instances let you use spare EC2 capacity in AWS at a huge discount, for example up to 90% off compared to on-demand pricing. So yeah, they're super cost effective, but the trade-off is that AWS can take them back at any time with just a 2-minute warning if that capacity is needed elsewhere. So because of that, spot instances are best for flexible, fault-tolerant workloads where interruptions won't break your system. So here's a quick example. Let's say you're running batch data processing, machine learning training jobs, or CI/CD builds. Basically anything where it's okay if the instance stops and picks up again later. And that's a perfect useful spot. So if they ask you when not to use spot, you have to mention critical or stateful applications like production databases or services that need guaranteed uptime. You could also score bonus points by talking about spot fleet or EC2 auto-scaling groups that mix on-demand and spot to balance cost and reliability. So now let's move on to the next question, which is, how does AWS CloudWatch help in monitoring? So at a basic level, CloudWatch collects metrics, logs, and events from your AWS services and applications. It helps you keep an eye on things like CPU usage, memory, network traffic, Lambda invocations, and so on. You can also set up alarms to notify you when something crosses a threshold, like if your EC2 instance CPU usage goes over 80% for too long. And it's not just about alerts, you can even automate actions. For example, you can trigger auto scaling when a metric hits a certain level. CloudWatch also supports dashboards, which are super handy for visualizing metrics in one place. And CloudWatch logs, where you can send logs from your applications or services like Lambda, ECS, or even on-prem systems. So, for example, you are running a web app on EC2 and want to monitor CPU and disk I/O. So, CloudWatch can track both, and if CPU spikes beyond 80%, it can send you an alert or even launch a new instance automatically to handle the load. So, in an interview, if they ask how to troubleshoot an issue in production, talk about using CloudWatch logs insights to search logs or setting up custom metrics for more detailed monitoring. Also showing that you understand how CloudWatch integrates with other services like autoscaling Lambda or SNS really makes your answer stand out. Now our 14th question is, what is the difference between Amazon RDS and DynamoDB? So this is one of those questions that really helps interviewers see how well you understand the types of databases AWS offers. So Amazon RDS is a managed relational database service. That means it uses SQL and supports database engines like MySQL, PostgreSQL, and Oracle. It's great when you need complex queries, joins, transactions, or structured data that follows a clear schema, kind of like a traditional databases. Now on the other side, DynamoDB is a NoSQL database. It's designed for speed and scalability using a key value or document model, and it delivers a single-digit millisecond response times, even at massive scale. So it's fully managed, serverless, and super fast. Now here's a quick example. If you're building an e-commerce app and you need to store orders and product data with relationships and consistent transactions, RDS is the way to go. But if you're building something like a real-time leaderboard for a game, where speed is everything and you don't need complex joins, DynamoDB is perfect. So if they ask when to choose one over the other, mention that RDS works best for structured relational data And DynamoDB shines for high performance and low latency workloads with flexible schemas. Also, DynamoDB's auto-scaling and pay-per-request model are great talking points for serverless applications. Now, our next question is, how does AWS DMS work? So, DMS is designed to make database migrations quick and painless with minimal downtime, which is a big deal when you are dealing with live production systems. So, it supports both homogeneous migrations like MySQL to MySQL or Oracle to Oracle, and heterogeneous migrations where you are changing the database engine entirely, like moving from Oracle to PostgreSQL. That flexibility makes it really powerful. So now here's what's cool. DMS doesn't just move your data once. It actually supports ongoing replication. So while your data is being copied over, it also captures any changes happening in the source database, keeping the target database in sync. That means when it's time to cut over, the downtime is super short, sometimes just minutes. So imagine your company has an on-premises Oracle database and you want to migrate it to Amazon Aurora. So with DMS, you can start the initial data load, and as your application continues running, DMS keeps replicating changes in the background. And once everything's synced, you just switch your app to point to the new database and you are done. So in an interview, if they ask how to minimize downtime during a migration, talk about DMS ongoing replication feature. And if they bring up schema differences, mention that AWS provides a separate tool called Schema Conversion Tool to help with that in heterogeneous migrations. Now, our 16th question is, what is load balancer and types of load balancers in AWS? So, a load balancer helps manage incoming traffic and spreads it across multiple resources like EC2 instances or containers to prevent any one resource from getting overwhelmed. This improves both the availability and scalability of your app. So AWS provides three main types of load balancers. Number one is Application Load Balancer or ALB. So this is a layer 7. So it can make smart routing decisions based on URL paths, host names or HTTPS headers. So it's perfect for web apps where you need advanced routing features like sending traffic to different backend services based on the request URL. So for example, if you have a web app with static content like images and dynamic content like user profiles, you could use an ALB to route traffic to your image servers based on URL path. And next there is Network Load Balancer or NLB. It is layer 4 and it's built for high performance, low latency workloads. It can handle millions of requests per second while maintaining high throughput. So if you have apps that need to work with protocols other than HTTP, HTTPS, or need extreme performance, NLB is the go-to choice. And then finally we have the Classic Load Balancer or CLB. Now this is legacy option that operates at both layer 4 and layer 7, but it's less feature rich compared to ALB and NLB. It's generally used for older EC2 classic instances and apps that doesn't need advanced features. Now let's move on to our 17th question, which is, what is a security group? So security group controls the inbound and outbound traffic for your EC2 instances or other resources. So it's like saying, hey, I'll allow certain types of traffic to come in and come out of my instance, but only from trusted sources. So what makes security groups special is that they are stateful. This means that if you allow inbound traffic, the response is automatically allowed outbound, even if you haven't explicitly set an outbound rule for it. So you don't need to create a separate rule for the response. So for example, if you're running an EC2 instance and you only want to allow SSH access port 22 from a specific IP range, you can set a security group rule that allows traffic to port 22 from that IP range only. And this will block all other SSH connections. So if you're asked about differences between security groups and network ACLs, you can highlight that security groups are stateful. So they automatically allow the return traffic and apply to instances, while network ACLs are stateless. So you need to specify both inbound and outbound rules and apply at the subnet level. So in short, security groups are a critical part of controlling network access to your AWS resources, ensuring that only trusted traffic can reach your instances. Now let's move on to the last question of our intermediate level, which is, how does S3 versioning help in data protection? So S3 versioning is like a backup system for your objects in Amazon S3. So when you enable versioning on a bucket, AWS keeps track of all versions of an object, including any updates or deletions. That means even if a file gets accidentally overwritten or deleted, you can easily recover previous versions of that object. So let's say a user accidentally deletes a critical file from your S3 bucket. If versioning is enabled, instead of losing that file permanently, you can restore the previous version. It's like having a safety net for your data. You can also combine versioning with lifecycle policies to automatically manage old versions, like archiving them to Glacier or deleting them from a set period. So if you are asked about how to protect against data loss, mention that versioning is a great first line of defense. You can also mention cross region replication (CRR) or cross AZ replication for additional data redundancy, especially for critical applications. So now let's move on to some of the advanced level questions. So let's start off with what is AWS Cloud Formation. So cloud formation allows you to define your entire infrastructure as code, which means you write templates in either YAML or JSON to describe all the resources your application needs. This is part of the infrastructure as code concept, where everything you need is coded, version controlled, and easily repeatable. And the best part is that CloudFormation automatically provisions and configures the resources in the correct order. This means you don't need to manually create and configure servers. CloudFormation does it for you and it handles dependencies too. So for example, let's say you want to deploy a complete web application stack with a VPC, subnets, EC2 instances, security groups, and an RDS database. So instead of manually creating each resource, you can write a CloudFormation template that defines all these resources. Then you can launch them with a single command, ensuring consistent and repeatable deployments across all environments from development to production. So in an interview, if you are asked about the advantages of CloudFormation, mention that it enables consistency, automation, and version control for your infrastructure. Automation and version control for your infrastructure. Also emphasize how CloudFormation works well with AWS Code Pipeline for continuous delivery, making it an excellent choice for DevOps teams. Now the 20th question is, how do you implement disaster recovery in AWS? So when it comes to disaster recovery in AWS, the goal is to ensure that your application and data are protected and that you can quickly recover in case of a failure, whether that's a server crash, data center failure, or regional outage. So AWS offers several disaster recovery strategies, each suited for different needs based on how much downtime your application can tolerate and how quickly you need to recover. So the first one is backup and restore. So this is the most basic strategy. You regularly back up your data and store it in different region or availability zone. And in case of a failure, you can restore the data from your backup. And then there is Pilot Lite. So this is a minimal version of your environment running in another region or availability zone. You keep the core components always available, but you don't have the full infrastructure running until a disaster strikes. And then there is Warm Standby. So a scaled down version of your production environment is running in different region or availability zone, ready to take over in case of a failure. And it's more than a pilot light, but not fully scaled. When a failure occurs, you scale up to full capacity. And finally, you have the multi-site active-active. So this strategy has fully redundant systems running in multiple regions or availability zones, meaning that both sites are actively serving traffic at the same time. It's the most robust and fault-tolerant option, ensuring no downtime during failures. Now the next question is, what are AWS organizations? So with AWS organizations, you can create a centralized management structure for your AWS environment. This service is particularly useful when you have multiple AWS accounts, like one for development, one for testing, and one for production, but you want to manage them all together efficiently. So here's what you can do with AWS organization. Number one is consolidated billing. So AWS organizations lets you consolidate billing for all your accounts into a single payment. So you can manage costs across different accounts from one place. And then there is service control policies, SCPs. So with SCPs, you can restrict permissions at the account level. This allows you to define what actions can or cannot be performed within certain accounts. So for example, you can prevent developers in your dev account from launching high-cost EC2 instances or restrict access to certain AWS services. And then there is organizational units, OUs. So you can group accounts logically into organizational units. This makes it easier to manage permissions and policies at a group level instead of individually managing each account. So for example, you could create separate accounts for development, testing, and production under a single organization. You might want to ensure that developers in the dev account don't accidentally launch expensive resources like high-capacity EC2 instances. So you can apply an SCP to restrict that. Now in an interview, if they ask about how to manage multiple accounts effectively, mention that AWS organizations gives you the flexibility to set policies, consolidate billing, and organize accounts into groups to streamline administration and enforce governance. So now let's move on to the next question, which is what is the difference between ECS, EKS, and Fargate? So let's take a look at the three main services for running containers in AWS, which are ECS, EKS, and Fargate. So each has its own strength, and choosing the right one depends on your needs. So the first one is Amazon ECS, which stands for Elastic Container Service. So ECS is AWS Managed Container Orchestration Service. It allows you to run Docker containers and manage them easily using the AWS ecosystem. So with ECS, you control the underlying EC2 instances that your containers run on. But AWS takes care of the orchestration part, making it easy to deploy, scale, and manage containers. And then there is Amazon EKS, which stands for Elastic Kubernetes Services. So EKS is AWS managed version of Kubernetes, an open source container orchestration platform. Kubernetes is widely used for complex containerized applications, and with EKS, AWS takes care of the setup, maintenance, and scaling of Kubernetes clusters. And this is a great choice if you're already using Kubernetes or need its extensive features and ecosystem. And then you have the AWS Fargate. Now, Fargate is a serverless compute engine that works with both ECS and EKS. With Fargate, you don't have to manage the underlying EC2 instances. Instead, AWS takes care of the server provisioning, scaling, and infrastructure management. And this allows you to focus purely on container deployment without worrying about the underlying compute resources. So if they ask you about the differences between these, emphasize that ECS is simpler and tightly integrated with AWS. EKS is for Kubernetes users needing portability and advanced features, and Fargate is great for serverless container deployments where you don't want to manage the infrastructure. Now, how does IAM Access Analyzer work? So IAM Access Analyzer automatically scans and analyzes the permissions in your AWS account to identify any resources that may be exposed to external access. So it uses automated reasoning to evaluate your policies and identify potential risks, such as when a resource is shared with an unauthorized entity. So here's how it works. IAM Access Analyzer looks for public access or access from external accounts that you may not have intended. Then it checks for permissions that allow access to external users, even if those permissions are not obvious. And then it generates findings, which are alerts that inform you of potential security issues, and it recommends actions to restrict unnecessary access. So for example, if you have an S3 bucket and you mistakenly set it up publicly accessible, so IAM Access Analyzer will detect this and alert you about the potential for data leaks. So you can then take immediate action to fix the permissions and secure your data. So if asked about IAM Access Analyzer, mention that it helps organizations proactively monitor and secure their AWS environment by finding resources with excessive permissions and preventing potential data breaches. So it's a powerful tool for ensuring least privileged access. Now let's move on to the 24th question, which is what is envelope encryption in AWS KMS? So envelope encryption is a two-layer encryption process that uses both a data key and a master key to encrypt your data. So the idea is simple but powerful. Data encryption. So first, you encrypt your data using a data key, which is a randomly generated encryption key. And then there is key encryption. Now, the data key itself is encrypted using a master key stored in AWS Key Management Service or KMS. So basically, this approach has two main benefits. Number one is performance. By encrypting data with a data key, you avoid the overhead of calling KMS every time you need to encrypt or decrypt data, which speeds up the process. And the second one is security. The data key is encrypted with the KMS master key, ensuring that even the data key is securely managed by KMS and can be rotated or controlled as needed. So for example, when you upload a file to S3 with KMS-based encryption, S3 encrypts the file using a data key, and then it encrypts the data key itself using the master key in KMS. So the file is protected by the data key, but the data key is securely managed and encrypted by master key. So in an interview, when explaining envelope encryption, highlight how it separates the concerns of encrypting data and managing keys. So it's a great way to reduce KMS calls while still maintaining high-level security for both data and encryption key. So now finally, let's move on to our last question of advanced level, which is what is a blue-green deployment in code deploy? So this is basically a strategy for deploying new versions of your application with minimal downtime and the ability to quickly roll back if something goes wrong. So the idea behind blue-green deployment is to run two separate environments. The blue environment represents the current version of your application, which is live and handling user traffic. The green environment is where you deploy the new version of the application. So here's how it works. You first deploy your new version of the application to the green environment, which is isolated from the blue environment. You then perform health checks to ensure everything works as expected. Now, once you have verified that the green environment is stable, you shift traffic from blue environment, the old version, to the green environment, the new version. So some of the key benefits are: number one is minimized downtime. So the switch happens quickly, ensuring minimal disruption to your users. And the second one is easy rollback. So if something goes wrong with the green environment, you can quickly roll back to blue without much impact. So for example, let's say you're using AWS Code Deploy for your application. So you create a green environment with a new app version, run health checks, and once it's verified as working, you redirect traffic from the blue environment to green. So in the interview, if they ask about blue-green deployments, mention that it's a great strategy, mention that it's a great strategy for ensuring smooth, low-risk updates. It allows for quick rollbacks if the new version has issues, making it ideal for critical applications where downtime needs to be minimized.
Alright, and that's a wrap on the top 25 AWS interview questions. I hope you found this helpful, and if you learned something new or if you feel more confident for your next interview, hit that like button and subscribe for more AWS and cloud related content. And drop a comment if you have any other questions or if you even want a part 2 of this. With this, thanks for watching and best of luck for your next interview.